So regular expression. So what I've done over here is I'm going to create a new file right here. Actually, create a new file. I'm going to work in idle because why not? Okay. Okay, and over here, what you'll notice is that I've got a file. What I've done is I've downloaded Dracula.txt from Project Gutenberg. So again, Project Gutenberg. Right, all I did was search for, what I did was I searched for Dracula. And I just simply downloaded Dracula by Bram Stoker as a text file over here. So now, so let's go ahead and basically, so I'm going to go ahead and write a file, classroom, ITP. This way it'll get uploaded onto GitHub. Okay. Regex starring Dracula. All right, so first things first, let's go ahead and get file reading. I did answer that. You can start with the tracks, but then you have to build off of it. You have to use the track. You have to add on. You can't just simply say, I finished the track, therefore my final project's done. So let's go ahead and first just confirm that we can read the file. Remember how to read a file. We just simply say, give me the file name. That's if it's just located in the same folder. And then we simply say R for the for read-only mode. And basically I'll just store that in text. Text is equal to that, run. And it seems to work. So, and then what we're going to do is that I will, I could simply, and if I want to iterate through it, I could go for line in lines. So for line in text, print line. And let's see, and we'd get quite a long piece of text. It's Dracula. It's a fairly, it's a novel. It's not necessarily a short thing. Also, remember, printing out stuff takes a while, especially in idle. Idle is very slow at printing stuff out. It just is. So while that's going, right, let's go ahead and open up our text file and actually take a look at it and see stuff. Okay, so here we go, Dracula. So we've got this. Now, personally, I find Dracula to be, Dracula is a famous vampire, but there's one more vampire who's even, who's more famous than him, of course. And of course, that is Count von Count, simply known as the Count. Come on, no comedic effect here, right? No, Vlad Tepes was actually, I think, one of the inspirations for Dracula. That was part of the inspiration for Dracula, Vlad Tepes. Anyway, what we're going to do is, I think we're going to say, so first off, let's go ahead and basically, so we find Castle Dracula owned by Count Dracula. So what I'd like to do is I'd like to find how many times Count Dracula is in this text, right? Now I could do that with basically doing something like this, which I could do simply say occurrences and set and is equal to 0 and say, hey, for line in text, I'll just call this occurs. If line dot contains Count Dracula. You can find that text on Project Gutenberg if you want to. This is just simply a good example of that. If line dot contains Count Dracula, I can drop it in chat if everybody needs it. So let's see. There you go. If line dot contains Count Dracula, occurs plus equals 1. Print occurs. And we would normally, and you'd think, okay, I'm good to go. Well, no. Oh, right. There is no contains. It's my bad. I was thinking in terms of Java. That's the issue with teaching multiple classes in multiple languages. You sometimes forget, oh, it's called this in. You sometimes use the other way of doing it from another programming language. So I use the in keyword here. So if Count Dracula is in the line, increment the number of occurrences. And it says there's only 9 occurrences of Count Dracula in the text. Come on, that can't be right. Let's go ahead and see though. Count Dracula. It turns out it is. Count Dracula occurs only 9 times in the entire novel. Although Dracula occurs 43, surprisingly short a few times for the title character, you know. Let's see. I could do text.count, yes. But I want to point out what is kind of the issue if I do this. Let's go ahead and see if it changes with Dracula. Right? What's the issue if I do this? It says 36 occurrences of Dracula. But if I look at my text file and find Dracula, it says there's 43. Why am I getting a mismatch here? There's a reason.
It's case sensitive.
I mean, it is case sensitive, but I mean, I can make it non-case sensitive by hitting a button right here. There. 36. Yes, it is case sensitive. So let's see. How many occurrences are lowercase Dracula?
Could it be because they have like parentheses or like commas next to it? Not parentheses, but like periods or something.
I mean, that won't matter for it. We're just looking for the substring Dracula. It's actually hyphenation? Not hyphenation. Could, although, let's see.
I think there were a couple times when it was in all caps.
Is that the case? Let's see. Dracula. Yes, there is some times where it occurs in all caps in the novel. So that is one reason why we get a miscount. There is one more reason though, which is that or we could get a miscount. I don't think it occurs here, and I tried to find it. Which is that what if with basically we had Dracula occurring more than once in the line. Right? Oh yeah, and Julie mentioned that in the text, which is what if Dracula occurs in the line? And that can be a bit of a pain, right? And we could use the count function there. But part of the reason I wanted to do this is also so we can replicate it using regular expressions. So let's do something very basic, and before we get into any kind of using anything advanced that we need in the regular expression grammar, we're just going to do some basic functionality just to introduce us to the regular expression library. So we can load up the regular expression library by going import RE. Okay, so we get our text over here. And what I'm going to do is I'm going to actually say, hey, text is equal to text.read. I'm just going to go and dump that thing into a giant string. Right? Everybody remember what this does? All this does is just basically say, hey, text.read, just simply give me the entire string. Okay. Now the reason for this is that let's take a look at the RE library. Now you can create objects, regular expression objects, using the Python library, which is great when you want to reuse stuff. But I find it to be very convenient to handle a couple things. Also, the regular expression documentation page on Python has syntax, such as like, here's what all the special characters do. We did not go over the clean star or the plus symbol and what those do. We will, or the question mark. They do very interesting things. And then there's back references, which I don't really cover because they're kind of weird. But anyway, let's take a look at, or I might cover them, but let's take a look at what we can do. We have some functions built into the library that we can use. So typically they take in two arguments, a pattern and a string. The pattern is what we care about, is what we're looking for, and the string is what we're looking in. Now, pattern is also a string, but we're basically saying that it's the regular expression pattern. And before I go on, I do want to say that string library has some stuff built into it that supports regular expressions, because I think, actually, or at least it does in Java. I'm not sure for here. I thought it did. Oh, entire regular expression. So you can use the regular expressions for some things in the string library. So, so there are some stuff there. So you'll find that they're built into a lot of programming languages besides just their library. Okay, so anyway, re.search, scan and is for the string looking for the first location that produces a match and giving us a match object. Okay, let's see. So match object, we don't really need to work. I'm trying to see if I can do that without that. RE match. If 0 or more characters at the beginning of the string match the regular expression, return a corresponding match object. Return none if the string does not match the pattern. Note it's different. So basically it says it's only looking for the beginning of a string, right? So searches anywhere, match looks at only starting at the beginning. So we're going to be using search a lot. Here's another good one. Find all. Return all non-overlapping matches of patterns in a string, such as, so, let's see, empty matches are included in the results. And we'll be using re.sub. That will be the most useful one for us. But okay, so we've got pattern, we've got match objects. So if you wanted to, you can create regular expression objects, which basically are regular expressions that are able to be reused and stuff. That gets into programming stuff. We don't really need to use that. Just know that there are match objects that we will be using as well. So let's go ahead and take a look. Let's go ahead and create a regular expression for Count Dracula. So let's go ahead and say, hey, Dracula Regex is equal to Count Dracula, right? Now what we're going to do is just simply say, what does re.search give us? re.search will give it the scan through the object looking for a match if the pattern is found. Okay. Re.search. We want to search the text. We don't need to give it any other additional information. And we're going to give it the Dracula regex. So you create your regex over here. And you can either put it in here or you can put it in the text over here, and it'll create what's called a match object, which for the final exam, you won't actually really be using that much. I'll be showing you what you'll be using for the final exam. So let's go ahead and print, what the heck is this match object, which I'm just calling Mo for short. Okay. Match object span 5925, 5935. Okay. What in the world is that? Well, let's go ahead and elucidate that matter. Text dot index it's not a regex, but I mean, it's a string, so it'll be fine. Over here, index gives you the first index in which something occurs. So, oh, look at that. It occurs at line 5925. So, the regex searched the text, said, hey, I found something from 59 to 25. Sorry, at 5925 to 5938. And I matched this text, Count Dracula. Sometimes it's obvious what we match because it's exactly what we're looking for. But sometimes it's not. For instance, there's some different spellings of vampire, some old texts like to do it as a vampire with a Y for some reason. So here I'm saying vamp, an I or a Y and an RE. So now if I run it, it's gonna give me, I can't find it because this isn't because this is a regex now and not something that can be different. It's something that's different. So not something that can be interpreted by the normal string library. So print match object, and it found vampire at this location. So, all right, there's another one I really like before I get into match objects, because typically when we're looking for something, we're looking for everything of something. So I like doing this one especially, which instead of search, I like doing find all. This one's probably one of the more useful ones, where we're basically, because you don't have to work with any regex like built-in object or anything like this. This one's fairly straightforward as to what it does. It gives me it gives me a lot of vampires. Basically, it finds all matches that we might find in this. Okay. Now this kind of seems weird for this occurrence, but that's okay. I'm just trying to demo different things. However, here is basically, here is where we kind of can have some fun. And that's where we get the re.sub. So re.sub. So let me go ahead and pull it over here, grab it and pull it over here. Sub is by far my favorite functionality for regex, because this is the reason I would use regex, which is that you take in 3 arguments. The pattern, basically the thing you're searching for, the thing you're searching in, and in between them you have what you want to replace it with. And you can actually give that a string or a function, which is interesting. I didn't know you could give it a function. You can make it more advanced, but basically we're going to look at something like this. So suppose you wanted to go ahead and basically make it Dracula very Sesame Street like. Okay, so whenever we see the word count, okay, then I want to replace it with, so let's go ahead and actually do this. We can do this all in one line, I think. Yeah, my list, sorry.sub. So I'm going to call it replaced re.sub. So I want to look for the regex count. And I don't care if it's uppercase or lowercase count. Okay, well, I'll show you how to deal with case sensitive stuff in a bit. Okay, and now when I see count, I want to replace it with count. I want to replace it with count, and then in parentheses, just like Count Von Count does in Sesame Street, because I have a 4-year-old sense of humor. Okay, and then I'm going to look for it in text. Okay, and okay, that does nothing because it stores it in a string, and this is a giant string. I just went through the entire text and replaced it all. It also went by really quickly. So let's go ahead and let's go ahead and create a new file to output this in. So I'm going to call it output. Output is equal to open. Let's open a file to write. Let's call it count Sesame, because we're doing a Sesame Street joke here. Okay. And then we are writing to it, so we're going to open it in write mode. Okay. And then all we have to do is say output dot, because it's just one giant string that we've got stored. We don't even need a loop, right? We just simply say output dot write replaced, which is, and you'll see, and then output dot close output dot close, which is great. Run it, and it worked. And so now let's go ahead and open up Count Sesame, and notice that it's basically the same size, slightly bigger. And now if I look for, so now over here, what I'm going to do is look for count. Okay. Oh, it's case sensitive, is looking for case sensitive count. So now notice it didn't find count as in, it didn't replace count as in country, which is interesting. Let's go ahead and see. Ah, so it did. So here, what happened is that it broke up country into count ari, which is not what we necessarily want to do. This happens a lot, but let's go ahead and find. But here we had the desired effect. Count Dracula. Right, that's Count von Count's verbal tick. So here's the thing: I only want to replace count when it's, when it's part of a word. Sorry, when it's not part of a word. So we want to basically say count. And then what's a good way to say I don't want it part of a word? Anyone?
Put a space before and after.
A space before and after might do it. Okay. So let's go ahead and see that. And then we would need to replace the entire, then we'd have to do this, where we take the space before and after. Right. This would get, if I replace this, this would get rid of the spaces as well. So let's go ahead and see. And now let's, the file should be reloaded. So we see country, that's perfectly fine. But now we have I must ask the count, all about them. That's pretty amusing. However, we got something else. I found my landlord in my land letter. My landlord had gotten a letter from the count directing him to secure the best place in the coach for me. Do we want to add a count after this too? I do, which gets us into another cool thing we can do. So let's go ahead and say, rather than just being white, so also if count starts at the beginning of it, of this, right? Count starts at the beginning of a line, it doesn't have a space in front of it, so we can't go We could say space or comma, but we can use groups to our advantage here. We can say, hey, count followed by any white space, anything that is not a letter. Okay, count followed by anything that is not a letter. Okay, and then we can say, hey, anything that is not a letter over here as well. But if it's at the beginning of a line, that still won't work. So here I'll show. Let's see. So we got count but if it's count at the beginning of a of we've got account. So it worked for that. So it got rid of the counts with the comma. So count Dracula, which I still find that very amusing. Okay, so let's go ahead and do count. Yeah, count Dracula. Now I can't find it at the beginning of the line, but I know it's there. Just like Castle Dracula, right? So I will go ahead and just put this at the beginning because I know that's going to be there. Oh, let me go. No, I need to alter the original text. So let me go ahead and basically put over here, Count Dracula. And then I want to put my other troublesome case over here, Count Dracula with a comma. Or sorry, with a period. Why not? Okay. So now save that, run, boom, output file. So this does have still have two issues. Okay, that's weird. Why that's there. Save. Let's go ahead and just put it below the title. Count Dracula and Count Dracula. There we go. Save. Run. Okay, here we go. So we got Dracula, Count Dracula, and Count Dracula. Great. So it didn't replace the okay, so it didn't replace the period like I feared it would. Okay. Now I don't know why it's like killing the white space like that, but we still, and it seems to have worked. Interesting. So that works actually. Although really what I wanted to do was kind of say it's optional that it has white space before it. So let's see. Now count Sesame. Run it. Would it Dracula count Dracula? Why is it doing that? Is it because I'm doing lines weird? It may be because it may just be because. Oh, I bet that's it. Hold on a second. It can be, sometimes text files can be weird with line endings and stuff like that. But anyway, it was fairly easy to replace stuff like that. Very, very easy to do that. The space before might be necessary. It really depends on what we're replacing it with. So let's go ahead and take a look at another example. One more kind of driven towards our text, because I'm not sure what's going on there. So let me go ahead and just simply create a new file. I'm going to work in Visual Studio Code now, because over here, let's go ahead and say, and let's go ahead and create a, actually, I bet you I already have one kind of created. So fall 2020, which is, do I have one? No, I do not. Let's go ahead and look over here. Let's go and look at creating a SSN target. So here basically is the kind of question I would normally ask. I say, here's a file, right? And what I'm going to do is let's generate some random social security numbers. Let's see. So let's go ahead and generate some random text in here. It's going to be really dumb. So what I'm about to do is really dumb, but I want to make a file that's and kind of should just show. Yeah, let's just go. Alice has an SSN of, let's say 111-11-11111. Bob has a social security number 222222222, and we need to keep that private. Again, 11111 and 22222222, not 1232. I'm just making just random text here, but the point being is that there's social security numbers in the text, or fake social security numbers in the text. Okay, so SSN, that'll be our SSN target file. Okay, so now let's go ahead and use what we've kind of learned over here to create, to basically say, to do what I would want you to do on the exam, which is fairly straightforward, which is create a new file where we've removed all the social security numbers. Okay, how do I do that? Well, first we need to create a new Python file. So SSN remover .py. Okay, so let's go ahead and do this. So we're going to need the regular expression library to make this easy for us. So import RE, and then we're going to have to also open up the file. So which I named SSN target. So open SSN target.txt. And we're going to open it in read mode, of course, right? So if we use the rubric from the final exam last semester, that's 5 points just for being able to read the file, which is as follows. The file, and then simply saying, hey, text is equal to the file dot read. And now there, I've read the file. Okay. That's 5 points on the final exam right there, just in 2 lines. Similarly, it was what we need to do is not print out a replacement, but write it out to a new file. We're creating a new file where basically we've removed all the offending, everything that's offending. So that would be just simply saying, hey, output. Well, we don't. We'll get to that. We'll burn that when we get to that. So now what we need to do is go and we need to find all the social security numbers, right? So let's go ahead and write a regex to do that for us. So SSN regex. And here's where I'm going to show you something called a raw string. Now, all that is just simply a string with the letter R in front of it. And what that enables us to do is to basically use backslash it, is to not basically when you have a raw, when you do raw strings, Python will basically say, okay, so escape characters aren't a thing. So when I see a slash, I'm not going to pretend it's an escape character, which is useful because otherwise you'd have to double up on your escape characters when writing the regular expression, which can be messy. So slash, so I can write /d or slash. So social security numbers, right? They're 3 in a row, followed by a dash, followed by 2 numbers in a row, followed by a dash, followed by 3 numbers in a row, right? Sorry, 4 numbers in a row. That's a social security number. And now let's go ahead and do, and let's just go ahead and see if we got them all, which is, so we'll do that by saying print re.findAll. Love find all because it's a very quick and easy way to test things. SSN regex dot. So we're going to look. So our target is the social security number regex, and we're looking inside of text. Again, it's just a giant string, which is the easiest way to do it. Find it all, and it found the one all. It found the 111, the 222, the 111, the 222, and the 123. So it found all of them. Great. So we found all of them. And if we find them, then we can, destroy them. So let's go ahead and do that with the other RE functionality that we learned. re.sub. Okay. re.sub. And let's see what we can do. We want to do, say, again, we want to look for the social security number regex, and we'll replace it with, let's go ahead and replace it with the text. If we find it, a social security number, we're going to replace it with the text redacted. Make sense? Yeah, find all will just simply gives you a list of them all, and so I could print them out. Just so it's a good way to see basically what in the text matches a specific regex. So social security number regex, we're going to replace anything we see with redacted. And then what are we looking in? We're looking in text. Then I will go ahead and print this out because it returns a string. I'm printing this out temporarily just to see, but like I didn't do this for Dracula because Dracula was ginormous. And so we've got the text here, Alice redacted. Bob has a social security number redacted, and we need to keep that private. Again, redacted, redacted, not redacted, although those are social security. Right? Gibberish there. I know, not my greatest work in terms of text, but it was. But now we see the social security numbers are redacted. Okay, but we've successfully replaced the social security numbers with this line. So these two lines collectively together were 10 points on the final exam. Cool. So 15 points, like just like that. So, and again, you could do this without using regex, but why? Why when this makes it so easy? Okay, so let's go ahead and see. What else? So now the next part of the final exam was, now that you've got it, replace these things, please. Okay. Which is, we'll go ahead and do that. Okay. RE dot. So now that we've replaced these things, stored in a string called replaced, I want you to write this to a text file. So we need to write this to basically saying, so I'm going to write this to a file called removed. Output is equal to open a file. I'm going to call it SSN. Actually, I'm going to call it SSN redacted because why not? .txt. Again, this extension doesn't really matter. I'm going to open it in write mode. So there, that's another 5 points because I've opened up a file for writing. And then how do I write this? Actually writing out the contents. I think that was another 10 points, which was just simply doing output dot replaced. I might be misremembering, but we're going to take a look at the actual question I answered. Output dot write. We're going to look at the actual question on the exam. Output dot close. And basically this writes it to a file. Now, again, this makes it easy for us to look at. So let's go ahead and see SSN target, SSN redacted, and there, that's the string that we printed out. So that makes it pretty darn easy for us. Again, this is like a final exam question. It was answered in 10 lines, including the white space. Not too bad. Okay. Now let's go ahead and before we move on, I do want and take a look at the final exam question. I do want to go back to regexer to teach you about a couple more things, basically 3 more things. One that we've kind of looked at. The first was we looked at, well, we can look at the right one right here because it comes down over here. So what is this regular expression? It is saying I would like, I'm going to remove the parentheses because we don't really need that right now. It is looking through for anything that is, so we've got, so what is this? It says it starts with A to Z. Can you just use to open with the new file? I don't want to overwrite the old file. So the reason I open a new file, I open this file and then I write it, and then it's always good decorum to close the file so that it actually gets written. You don't want to use the original file to open up a new, you don't want to use the file to open that up. It's bad practice. You could do it, but it's bad practice. Okay. So anyway, we've got this character set over here. Says this should start with anything from A to Z capitalized, followed by a lowercase, anything that's alphanumeric, a word character, alphanumeric. So A through Z, A through Z and underscore. I mentioned A through Z twice because it's capitalized and uncapitalized. And then we have the plus, which is quantifier, precedes one or match one or more. So this is an A through Z, a capital letter followed by at least one word character. So cheat sheet, reference, help, this capitalized U, save, but not this one as well. Okay, so let's just go ahead and remove this A through Z. So this matches anything that is at least one alphanumeric character long. So this is a pretty cool thing, at least one of. What maximum does it go to? It doesn't care. It's pretty cool for that. The other thing you can get is the clean. So another thing you can get is the clean star, which it shows up a bit less, but it's very useful. And that is the well, let's see. So this is the dangerous text. Dot, notice that everything just got highlighted, dot star, by using dot star. Dot matches anything. And this is the clean, in the clean star, the asterisk matches 0 or 1 of anything. So for instance, let me go with the classic mathematical example. So if I were to do A, B star, it matches A, B, A, B, 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 A, B, 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 B. It matches basically as many. Yes, it still holds for Python. It's just simply where are you doing it in the browser or not? So this all regex formats are pretty much the same across the board. Pretty much every programming languages use it. So everything I'm mentioning here matters. So this is at least, so this is 0 or more of. So you could do without it, or you could do with it. Anyway, so enough of that theoretical stuff. Let's go and look at the final exam question that I showed you yet on Tuesday, but I want to do it again today because it was a good one. I wrote it and I'm proud of it. Mildly sad that I showed it to you, but I thought it was such a good question that, you know, I should come up with a different one for this exam and use this one as a kind of, you know, example. No, I don't need to see grades. What I need to see is quizzes. Final exam. Back. No, makes it non-trivial to get into the final exam, which is annoying. Okay. Right, so this is the final exam from last semester. So let's go ahead and copy this question to look at it in here. Okay, that's all we needed. So okay, and Alt Z, I believe. There we go. So this is we're going to save this in final exam 2020.py. Okay, and there we go. And now let's go ahead and just simply multi-line comment this. It didn't capture everything, but it captured everything I needed over here. So write a script or a function that, given a file name, reads the contents of the file and creates a new file with all the TU email addresses removed or censored. A TU email is an email like mine, tug85861@temple.edu. That's my actual Temple, you know, the TU, the non-aliased one. A TU email starts with the letter, specifically TU emails start with the 2 letters T and U, are followed by another letter, then 5 digits, and then finally with @temple.edu. So we want to make sure that we grab Temple files. And so here we go. For this input, a correct program, like for this input file, and I give you, let me go back over here. I give you, I had actually a, so let's see. So what I'd have to do over here is, there we go. So I hosted these on GitHub on exam files. That was really clever of me. And I had basically the, this file. So I had an input file and an output file. Basically, here's what I wanted your program to do. Professor Rosen's personal email is profandrewrosen@gmail.com. All emails sent to tug. tug85861@temple.edu or andrew.rosen@temple.edu are redirected there. He is not tuz12345 or nor is his email tuf at temple.edu, although that would be amusing if that were the case. So, and then if we go to the next file, let's see. So Professor Rosen's personal email is profandrewrosen@gmail.com. All emails sent to redacted or andrew.rosen@temple.edu are redirected there. He is not redacted or redacted. So why didn't this one get removed? Because it's not a TU email address, right? It's not, it doesn't start with TU. But this is like saying, so for a lot of the questions I'll give you, here's an example input. If your program works correctly, it should match this output. So let's go ahead and basically copy this. And we will just simply use this as the, and I'll call it input 1. Okay. And so grading, 5 points for reading the file, 10 points for correctly identifying TU emails and only TU emails, right? So just because it has an @ in it doesn't mean it's what we're looking for. I don't want you to get my profandrewrosen@gmail.com or the andrew.rosen@temple.edu. I only want the TU email addresses to be removed. 5 points for successfully writing a new file and 10 points for redacting. Okay, so there we go. So first things first, let's go ahead and read the file and get our first 5 points, which is I'll say the file is equal to open. Which was input1.txt. Actually, hold on. Wait, let me read this before I go ahead. Write a script or a function that given a file name. Even better. Def email TU mail remover, right? Oh yeah, I'll be grading these manually. I'll be grading these manually because it's these are getting to the point where an auto grader just won't cut it unless I spend a lot of time automating that task, which I eventually will do, just not this time, just not this semester. TU mail remover, and let's go ahead and simply say file name. Right now, why am I writing as a function? Because it told me to write a script or a function that given a file name. So I'm going to do that, and so I would do. So let's go ahead and again, open this file. Open file name. Wait, no, just so we're given the string. So file name, that's our string. We're gonna put it in read mode. And then we're gonna say the file is equal to open that. Okay. And we'll need to call it at some point, which we'll do with TU mail remover input1.txt. You can get partial credit on individual tasks depending on the task. For reading the file, it's pretty much all or nothing because I consider that a very simple task to do. Because all you have to do is to read it is simply say, hey, text is equal to, or whatever your variable name is equal to the file.read. And boom, If you do read lines instead or something else, that's perfectly fine. I don't really care how you read it. This one's just simple, much simpler. So now we got this. Why is it saying? Okay, not accessible. Remove it. Oh, thing, because I haven't used it yet. The file does not match the regular expression. It wants me to do things underscored because of course it does. Okay. It wants me to make it Pythonic, which is to use. Okay, I guess I'll do that. Okay. So now let's go ahead and do correctly identifying the TU mails and only the TU mails. So to do that, I'm going to need to write the regex. So I'm going to call this TU regex. So I need to match the TU email addresses. So let's go ahead and start that. Which is to do that, I need, again, I'm going to put a raw string. You can remember when using regular expressions, just put an R in front of the regular expression you're writing. So let's think about this. So we need, so let's start with the easy part actually, which is the end, right? The end is always the same, right? It's the beginning part that's not the same, right? What happens if you don't put the R in front? It gets messy because you have to. So if you don't put the R in front, if you want to match a digit, instead of doing that, you have to do //d to so you can get a single slash. So just use that to do. It's because both Python, in that case, both Python and the regexes would be needing a backslash for an escape character, and then it gets messy. So you'd have you have to write two. It's stupid, but that's why you have raw strings. So okay, next thing I want to do. So I want @temple.edu. Everything ends with @temple.edu, except remember, in regular expressions, dot means any character, so I escape that character. So this will match anything that is @temple.edu. Okay, let's go ahead and test that out by saying, let's go ahead and just test this out actually, just to make sure we're right by moving on to the other file point. Okay, 5 points for successfully writing the file and 10 points for removing or redacting the TU emails in the other file. So let's go ahead. I like to double check things, so I could use, actually, I can just, instead of moving on, I can just use the find all, right? So print re.findAll. Oh, got to import re for regular expressions, import re.final, find all, TU regex in text. So I'm going to go ahead and run it. And it found 1, 2, 3, 4 @temple.edu's. And in our input file, there is 1 @temple.edu, 2, 3, and 4 @temple.edu. So it's finding them all. Great. So, okay, wait, this backslash or the R? Oh, so the dot is any character. It's so in regular expressions, dot means any character. So if that was the case, if I just put in the dot without that, Templar edu. Yes, there's a final and a final project. Then we will find, let's see, our temple. Input 1. Oh, right, I didn't have the @ so. I'm going over the final right now, and I've explained what the final will be like for the past 5 classes, I think. So Temple edu. So it catches that as well. So notice that if I'm doing Regex and I have it set to temple.edu, print find all Regex text. So you've got temple.edu, 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 and then you've got templer.edu. Sorry, templer.edu. So the dot is any character when you just use it like this. It's a special character in regex that means anything. But if I'm literally looking for a period or a dot, I can escape it and just simply put slash dot. And notice it highlighted red. That means it knows that I'm looking for that. So, okay. Now we've got that. And let's see, our temple edu. So now we'll only find 4 of them. That's perfectly fine. So now we can go back to working on our regex now that we've kind of got that we know that it's working. So we've got the @temple.edu part. So again, I'm working backwards here. You can work forwards instead. But next thing that comes before it is 5 digits, right? 5 digits is easy. A digit is /d, right? And then we need 5 of them. So we can do it like that. And because somebody's bound to ask it in chat, yes, you can also do it like that. Both are equally valid ways. It's just that, you know, at a glance, it can be hard to tell the difference between this and this. Okay. So you've got, so 5 digits. So if we run this again, we find now this one, and this one. All right. And now we need to find the ones that start with, we then finally temple email start with 2 letters, T and U, and followed by another letter. So we need, before these 5 numbers, we have another letter, any letter, and it can be any letter, right? And that would be, so to do any letter, we're just going to create our own character class and say A through Z. If we did /W instead, that's not any letter. That's anything that's A to Z, capital A to Z, or an underscore, or a number. So we want, if it's any other letter, we're doing A to Z. Now, if this seems harder than just like, why don't we just use, just like parse the text and go through it like substring by substring? Try that. And you'll find out why we're using regex very quickly. Yes, it only does lowercase letters like that, unless I throw a flag on this to say, hey, I want it to be case insensitive. But anyway, T and U, and then finally TU. To start with TU. So this says a T followed by a U, followed by any letter, followed by 5 digits, followed by the @ symbol, followed by temple, followed by a dot, followed by edu. And if we run this, we find that we get TUG, temple. And so now the reason I have it designed like this, was also because I knew some students who decided not to study and just simply jump on the internet for answers. They might decide to go for typically when you're trying to like not do your own work, you typically like look for something adjacent and copy paste it. So remember that if you put in something that found more emails than this, specifically this email and this email, this email and my and this email over here, then that's a bit of a then that would be wrong for that portion. But if you got this portion wrong, the identifying, but let's say you overextended, right? Maybe you forgot, maybe you just didn't do a portion of this correctly, you'd still get partial credit on this. Or if you grabbed all emails, I'd still give you partial credit on that, as long as you did the rest of it right. Okay. Or as well, sorry, I'd give it independent of those. Each of these parts of the rubric are independent of each other. So this part would be worth 10 points if you got, and you can get partial credit on that. So now going on to the writing to a new file. So we need to open, so we're going to do output is equal to open. And we're going to go and look at file. Let's see, we're going to go ahead and say, I'm going to call this output.txt because I'm boring like that. Call it output1.txt. And then we're going to put it in write mode. And then we just simply say, and so that's how we would write the file. Now I just have to know what I'm writing. So to do that, I need the next part of that, which is 10 points for removing or redacting the TU emails in the for the new file. So for that, we're going to use the re.sub. And because I didn't say it outright, sub is for substitution. So what we're going to do is we're going to say, hey, I'm looking for the TU regex. I want to replace it with, and you can replace it with empty string, or in this case, I like doing redacted because it shows that there was something there and we deliberately removed it. And then text. And then so that part, so this line was worth 10 points and this line was worth 10 points. That's all you had to do with that. So once you create the regular expression correctly, it's very easy to replace everything. And so now what we can simply say is to get those final 5 points, we simply say output.write replaced output.write replaced and then output.close to close it up. And so now we can actually test it by writing a file onto our computer. And then what you do is you'd simply copy paste your code into the text window. So let's go ahead and see what output1.text looks like. And look like it matches what we were aiming for, which is we've only removed the TU temple emails and not Andrew.Rosen. And yes, when you do A through Z, it's only undercase letters. It says write is not defined. Did you do it like this? Then I don't know why it says output not why write is not defined. I'd have to look at more of your code, and also I'd have to look at more of your code to be able to remark that. But basically, this is all we needed for 30 points on the final exam. No. Can we try the function with the input file? I mean, I think we just did. That's what I just did. I did do that. It got the input file. And then we got the, and then I got this file. Issue with the tabs. Oh, those kind of tabs. So with our input file, so this was our input file, this was our output file. So this is the kind of question you should be expecting to get with this. Now you don't have to use regex for this, but regex makes it really easy. Again, it was 1, 2, 3, 4, 5, 6, 7 lines plus the function over there and the import. That's all it took to do this problem. Doing it by hand is way more difficult. Okay. Or sorry, doing it by using other stuff is way more difficult. Also, it didn't take that long. I mean, I was explaining it while I was going and it took me a bit, but it really doesn't take that long if you know, hey, and break it down. So basically so again, if you want kind of exercises to like work on this kind of stuff, again, I would suggest automate the boring stuff. Going over to automatetheboringstuff.com, pattern matching with regular expression. There's some other, they're answering some of the questions down here. And working on through some of the exercises over here. They do show you how to do some of the substitution stuff and go into a bit more detail about it. So, if you're having the no such file or directory error, then it's probably not in the same folder as what you're looking as the program you're running. The program you're running has to be in the same place as the file you're reading, unless you give it the full path to the file you're reading. So, okay, now so again, just to repeat this, the second question on the exam will be will also be 30 points. It is the what you know nothing about this except it's completely new and it's something you haven't seen before, but it's built into Python and I tell you how to use it. And the final question, which is 40 points, will be, here's a game. I want you to simulate the game using Monte Carlo approximations. We'll be doing more exercises like that closer to the final exam, because I do believe in doing final exam review and working on interesting problems. That's the plan I have for the next couple of lectures, which is doing some interesting, challenging problems and that require some critical thinking and kind of showing you some programming tricks that you can't really learn until you find a problem to apply them. So, but it will be something along the lines of telephone numbers or emails or social securities or some other ID number that I need you to remove from this. Right. Let's see. So, all right, I think I can stop sharing at this point. So yes, we will have and yes, to reiterate, we do have a final exam. This is what I've been going over. Okay. So, okay, and as for additional, what I wanted to say was additional things for Regex. I just got to put this on my to-do list so I remember to do it. I'm going to be adding that additional assignment again, which is completely optional. It will replace the lowest grade. So I'm giving you a new assignment, but I don't want to, if you're already overloaded with work, I don't want to make you have to do it. So what I've done is rather than dropping 1 grade, I'm going to drop 2 grades and I'm giving you a new assignment. So if you're already happy with what you have, no need to do it. And if you want to replace a grade or you missed something, here you go, grade to replace that, you know. So and it will be purely on Regex and using a dictionary file. So basically, here's a list of all the words that your computer recognizes and answering questions like, are there more words with cat or dog in them? How many words end with ION or IONG? How many words have 2 vowels in a row? How many words have 2 vowels but not in a row? Those kind of questions. How many words are there without any vowels in our dictionary? So those are the kind of questions that we will be answering. Upload. as well as stuff like creating a password, as well as like harkening back to the old, to an exercise we did very early on in the semester about creating secure passwords. But now you can create a password detector as well. You're not, so you don't have to demo the project proposals. No. And there's two project proposals. There's the pre-proposal, which you did for brainstorming, and the proposal, which we're giving you this week, which is you telling us what you're actually going to do. I should be updating Runestone hopefully tonight, now that I finally have the chance. And now that all the quizzes are done. So I actually, if it ends up, so if you tell us what we're going to do, hopefully I can point out what parts would be too complicated. If it ends up being too complicated, then talk to me. I might just be interested in seeing what you have gotten done in the meantime. In lab, you'll be working on anything you have left over, as well as sorry, like, why did I suddenly disappear from this? Why am I all the way at the end? Okay. And yes, I'll be recording this. Are we gonna have quiz 6? Probably not. Let's see. And yes, I'm going to be posting this lecture recording because I try to post all of them. Just I'm not always up to date on them.